Hi, I'm Josh Kinney, and this tutorial will be discussing classes within Swift. Now, if you're not familiar with classes and you haven't been following along with these videos, I highly suggest you go back at least and watch the Structs video, and I'll link that in the description below. But let's go ahead and begin. So with a class, they're very similar to structs in the same instance that they can hold both methods and properties, whether it's stored properties or, as you saw in the last one, computed properties. So let's go ahead and look at a basic class, and you're going to see right away that there's an error saying this trail class has no initializers. So as you've seen, and I have the initializer here, but I have it commented out so you could see this error. So this is the first thing that is different between a class and a struct. If you remember, you could just have these properties inside a struct and have no issue. It would accept that right away. With a class, however, you do not get that first initializer that you get free with the structs. You actually have to call that. So once you call it, so I'll go ahead and uncomment out this line, you'll see with an init method, as we've seen in the struct video, so you're literally taking a name, a length, and a location, and you're initializing this, and you're setting this self.name to the name. Now, one thing I want to talk about real quick is this self keyword. I used to get really confused on this in the beginning of my journey. And all this is saying is, if you take the self dot away, it would say name.name. Well, Swift doesn't really know where to go with this first name. So saying self is saying, hey, the self of trail dot name. So it's going straight to this name here. And then is equal to this name. Well, this is inside the initializer, and you can see it's highlighted when you click on it. So you're setting that to equal whatever you pass in with this initializer. Okay, so that's all that's doing. So you're going to set these all together. Now, what this class is kind of replicating is trails. So if you were to go to a trail around your area, you could have a name of the trail, how long in miles is the trail, and where is the location of this trail. So let's go ahead and see what this looks like if we were going to initialize this. So I'm going to do let elephant rocks, and I have a place near me called Elephant Rocks, so I'll use that equal, and we're going to set that to trail and pass this in. So you'll see the name. So I think it's called the elephant loop, trail loop. Not a big deal if it's not correct. It is exactly 1 mile long, and this is located in good old Missouri. Okay, so now that's the Elephant Rocks is now going to be able to access each of these because we just set it. So if you want to look at it just like structs, you could do this. So we're going to do elephant rocks dot whatever you want to look at. Let's say location. And you can print or you can play and you can see Missouri. So it knows because you set Elephant Rock location to be Missouri with that initializer. So that's the first difference between a class and a struct. You have to tell it what this initializer is in a class. With a struct, it's already being worked behind the scenes. Class inheritance is the next thing I want to discuss with you. So unlike the struct, a class can actually use the properties from another class in its own and also add new properties on top, which I'll show you that in a second. But I want to give you one quick example which you'll see a lot in your code. When you're developing in Swift, sometimes you want to make, let's say, a custom button. So whenever you make a class of custom button, you would want to do a colon and then do UI button for that subclass. And what that's going to give you is everything you can do inside that UI button that Swift has already given you, plus whatever you want to add in with your own button. So you see that a lot, and that's an example. Let's go ahead and show you in code a shorter example. So I'm going to go ahead and paste here a smaller class, and you can see it is a subclass, and you can make it a subclass with a colon here of trail. And trail, of course, is this one up here that we did previously. So you can see you do an init method just like you did here, but you instead of putting these variables here, we put it inside this init method. So we're going to have a name variable that is going to be, or I'm sorry, a property that is going to be of type string, and a link property only because I want to change the length. So if I didn't want to change the length and I wanted them all to be the same, I could get rid of this since that property is already up here in the trails. And I could leave it similar to what I did with this location. You can see I named it California because I'm going to say in this instant, all these bike trails are going to be located in California. So I'm not going to have to relist that up here. And then the next property for the bike trails is a speed. So you don't really care about the speed with the trails, but you may care about how fast you're allowed to go with the speed when you're on a bike. So let's go ahead and see this magic happen. So I'm going to go ahead and and print out something. So we're going to say let St. Joe, which is another park, equal, and we're going to do bike trail. And then we're going to do the parentheses, do the initializer. I'm going to hit enter, and you'll see right there, name, length, and speed are all that show up because those are the only three initializers inside here that we are adding. Okay, and now you see one thing that is similar. There's a name property up here in this trail. It's overriding that with its own name, and we're saying, hey, whatever this is equal to is what we want to use, not this one. So we're going to go ahead and fill this out. This is called St. Joe State Park. And this is in Missouri, not in California, but that's not going to matter. The length of this, because I did want to change the length, I put it down here. We're going to say this one is 5.8 miles. And then the speed is 55 miles per hour max. You can go in the park. And now within St. Joe, look what you can actually access now. St. Joe dot, you can do length, the location, or the name. So you can actually access those three. And you can print and grab it right there. So it can actually grab these same things that you set from this other class. Again, going back to that button, if this was Swift's UI button and you wanted to access that with your new custom button, you can grab anything inside that Swift UI button that you want to use. All the code that Swift has already brought to you and created, you can use now within your button with a simple colon and then the name Swift UI button. That's it. And now you're able to access everything in that class. So that is class inheritance, which you do not get with structs and you do get with classes. All right, let's see the next thing. All right, so real quick before we move on, I want to touch on two things. The first thing is when you create a class, so for instance, this trail right here, it's not of any subclasses there, it's just trail. This is the parent class of bike trail because bike trail is the subclass of trail. So the parent, and this is the child. Another way this is called sometimes is the super class. So if you see this super.init, which is the next thing I wanted to talk about, they're talking about the init method in the parent class. So that's what that super is. And by default, Swift makes us do super.init when we are trying to use this class so we don't mess up. So say something important in this init method up here was happening. Well, if you do a super.init, it would make us see that and change or do what we need to do with that code so we don't mess up anything. So it's basically a safe way of getting into this class and making it work for us in a sense. Okay, so the next thing I want to talk about is overriding methods, which is another thing that these classes can do that the structs cannot. So let's go ahead and paste this out for me to save some time. I have a class here, and the class is called cow, and there's a function called cow sound. And of course, cows say moo, so that's what it's going to be printing out, just so we know we're accessing that. I made another class called my cow, of a subclass of cow. So again, cow is the parent, my cow is the child class. Okay, and right now I'm not going to put anything in here, but real quick, some might wonder why I do not need an init method inside here. Well, it's a class, and the classes don't come with that free init like struct. Why are we not doing that? And the reason why is there's no properties right now that we need to initialize. All we're having is one function show up that we can grab and use. So there's no need to have an initializer. Okay, so now the last thing I'm going to do is grab this. So I said let princess, because you guys should know princess is my cow's name, is equal to my cow, and then you initialize that. And you're like, well, there's nothing in my cow. Aha, but still, since it is a subclass of cow, it can access this function. And you can see that from here. So princess dot, you can access cow sound. And the way you can know this is right here we have print moo. I'm going to play this right here, and you're going to get moo. So it's accessing that and working with it. Now how you override that method is we can do that exact thing right here, but instead of actually saying print moo, let's change it to something else. So you have to do override keyword first, and then from there we want to do a func. Call this the same thing, which would be cow sound. So cow sound. Okay, and then from there we're going to go ahead and do this. You curly brackets for your function, and inside here, instead of print, we're going to print, or instead of moo, we're going to print bark, because this cow is cooler than your dog. All right, now let's see what happens. So I'm going to go over here and hit the play button. And you see, it no longer is saying moo, because we did an override of this method in our own class in the exact same name of the method and named it something else. And the way we were able to do that is with this keyword here, override. That is some powerful stuff, guys. Let's go on to the next one. Okay, so this next topic is going to be quick and easy. So we've been talking about inheritance with these classes and how you can access, for instance, from my cow to cow, we can access this function and we can change it to whatever we want and we can use it. What if you wanted to prevent developers or other people from accessing your classes and changing them up? What if you wanted to make that the last class or the final class? You can do that with the keyword final. So as you can see, I put final in front of this class, my cow. And if someone was to go, for instance, make another class, so I'll paste this, called your cow instead of my cow, of type my cow, and do this exact thing. So we want to override this function, cow sound, and print. And you can, we'll erase some of this just to change the lettering. Doesn't matter. So, but just to print something else, just like we did in this example here, you will get an error. And the error will say, hey, you can't do this inheritance that you're used to from a final class. So that word final is saying, hey, this is the last class of this. You can't take this stuff and use it. Now, you can access that still. You can access this function inside of my cow, and you can use whatever it is there that's printing out. You just can't change it. Okay, so that again is called final classes, and you use that with the final keyword. Let's move on to the next. All right, so this next thing I want to talk about is mutability. So if you have a class and a struct, and they are both constants, with structs, you cannot, say you have a property in there, you cannot actually change the value of that property once you set it in there. With a class, however, you can. So let's see what I'm talking about here. So I have a class here called my name, and it's got a property that's a variable of name, and it is set to Josh Kinney. Now another thing I want to point out, and I want to keep pointing these things out because there were things I was confused about in the beginning of my Swift journey. Some people would ask, well, why don't I have the init method here? Well, the reason why you don't have the init method is because you're telling this var name what it's set to already. If this, like a struct, if I was to set this to be of type string, then you'll see that it'll say, oh, well, guess what? It's not actually initialized yet. So you need to have that initialize going off to tell it what to set it to. Okay, but since we are equaling this to something, you don't have to have that initialize going off to tell it to. It wouldn't make sense. Hey, a name, you already set to Josh Kinney, but let's go ahead and do this initialize function and set you to something else as well. It's just already there, so that's why you don't need it. However, going back to the mutability here, if I wanted to come down here and do this, so let Chris is going to equal my name, and then I'm going to say Chris.name is Carly Chill. Funny name, I know. And then I want to print Chris.name, and it's going to print out Carly Chill. So it's going to be, even though this is a constant class, it's going to be able to change this name. If you do not want it to do that, the way you prevent that is with the let property there. So you do let name instead of variable or var, and it'll say, hey, you can't assign this because it's a constant, and it'll protect you that way. And if your class is a constant, you're not going to want it to be changed. So using let is recommended. So to wrap this video up, I want to talk about the one famous reference versus value types within structs and classes. So that's a big difference between the two. So let's talk about that before we end this video. Now, to keep this super plain and simple, the big difference is that the reference type, they share a single reference for the data. Okay, and as far as the actual value types, they keep a unique copy of that data. Now, let me show you that. I have down here already two items. One is a struct planets, one is a class computer. Okay, so let's look at the planet first. We have one boolean that's set to false. Then we have a variable that is called Earth, and that is equal to the planets. And then we have Mars that is equal to Earth. Now, in theory, all these basically now are equal to this planets. They can both access this is flat. Okay, now let's do something different and change is Mars flat and change it from false to true. Okay, and now let's go ahead and see Earth is flat, Mars is flat, and let's hit play. And you're going to see Earth is not flat because it's false up here, and we only changed Mars to true. So Earth is flat, that's false. Mars is flat, that's true, which is exactly what we told it to be right here, and it's working exactly like it's supposed to. That is a value type. They both have their own copy of this value. So let's go ahead and look at the class and the reference type with that. So this is computer, and we have one boolean as well. They're the same exact thing, they're just different names. And this is computer is greatest. Okay, now we're going to let Windows equal computer. We're going to let Mac equal Windows, exactly like we did up there. And then we're going to do Mac is greatest, and we're going to change that to equal true from false. So technically right now, if we were a struct, we would get Mac is greatest is true, but Windows is greatest should still be false because we never changed it. However, they both changed to true. Look, true, true, because it's going to go all the way back up here as the single reference. They're sharing that data, and this is now changing to true because we changed it here. So it changes for everything within that class. Whereas in this struct, it only changed for the single thing that we changed to true. That is the big difference. And that is going to wrap it up for classes and the difference between structs and classes. As always, if you guys have questions or comments, feel free to leave those below. Those links that I referenced earlier will be below in the details section. And if you like this or got any benefit or knowledge out of this video and you'd like to see more, hit that like and subscribe button, and then you will be notified when I put out more content. Thanks.